today. Today we're going to be working on adding and subtracting rational expressions. So just like you would with normal fractions, 1/3 plus 2/3, we want to be sure that your denominators going forward have a common denominator. So for our first two examples, you'll notice that the common denominator matches, which means when they match with your normal functions, we can add them together. We can really say this is 1 plus 2/3. Notice that the denominator stays the same. It's the numerator that's going to change. And then you simplify. So from our perspective, notice that your 3's match, which means we can write this under one denominator. We can go ahead and add your numerators together. So combining your like terms, x plus 5x makes 6x minus 4. And in your numerator, you definitely want to check to see if it's factorable. In our case, 6 and 4 share a 2 in common. 3x minus 2, 3. And that would be your final answer that I would expect on the test. You cannot just cancel out the 3 and the 6, leaving behind the 2, because this 4 does not have anything in common with the 3. Instead, it's working as a team in your numerator. Now let's try it again with below. They both have a 7 in the denominator, so we can combine 2x plus 5 minus x. 2x minus x makes x plus 5, and that's as far as you can go. Now I'll do a few more where they match. I'm going to attempt number 6. So you'll notice that in number 6, their binomial down below still matches. So when they match, that just means that it's less work for us, and we're going to be looking to your numerator. So we have 2x plus 3, and this whole binomial is being subtracted. So put a parentheses around it and then distribute to get your real numerator. Notice that switches your signs. X plus 5, 2x minus x is x, 3 plus 3 is 6. Now let's try it again with number 7. So x plus 4, 2x plus 3, putting parentheses because you're subtracting, and that way you can distribute evenly. Negative x plus 7, x plus 4 on the bottom, and you have x plus 10. Now let's repeat this process when we have non-like denominators. For example, let's take a look. Well, let's do one more where it's similar, actually. So let's take a look at 14. Actually, no, 15. Let's do 15 first. So in 15, you'll notice that these polynomials are the exact same. But when you see a polynomial like this, we want to go ahead and factor it. So while they are still the same, you definitely want to factor to see, does anything cancel out with the numerator to be more simplified? So if you take x squared minus 5x plus 4, we're looking at factors of 4, 1 and 4, 2 and 2. And of those factors, what can get you to a negative 5? Well, 1 and 4 can get a negative 5 if we subtract them both. It'll be more negative. And when you multiply them together, they'll create a positive 4 like you do here. So your factored form is x minus 1 and x minus 4. So once you have everything factored, let's go ahead and tackle your numerator. So we have 3x minus 4 plus, and the reason why we don't have to put parentheses around when you're adding a binomial is that they won't change your signs here. So you're still working with 3 minus 2x. This will then create x minus 1, x minus 1, x minus 4. The 3 minus 2 will create just the x minus 4 plus 3. And this way you'll notice that your x minus 1s will go ahead and cancel. You wouldn't have been able to see that if you didn't factor out the denominator. So your final answer is just 1 over x minus 4. Let's try it again with number 16. So you'll notice they have the same denominator, so let's go ahead and factor. We're looking at factors of 7 that can get you to a negative 6. That means we have to add 1 and subtract 7 to get the negative 6. And when you multiply them back together, you get negative 7. So x plus 1, x minus 7. We can go ahead and add your numerators. So you have 5x minus 4x to just make x. Negative 4 plus 5 will make plus 1, which again cancels. And you're left with 1 over x minus 7. We're going to do it once more with 18. So with 18, let's go ahead and factor below. Now this one is one of those that I really like. It's called your difference of two squares. You'll notice that difference meaning they're being subtracted and both of your terms are perfect squares. So when you go to factor, it's x plus 5 and x minus 5. If you don't know how to factor these, please go back to videos on how to factor. Because we're subtracting here, we're going to make sure that we're distributing evenly by using parentheses. So you get x minus 5, which cancels. Get 1 over x plus 5. Now let's take a look at maybe 19 and 20. So you'll notice that 19 and 20, we're now working again with monomial terms down in the denominator. So let's take a look. Because they're monomials, these x's are going to be the exact same. In other words, unlike if you had a binomial across from it, right? Some of these ones are over here, let's see maybe up above. So these are actually pretty big. So that's a better example. Well, there are not really good examples of what I'm trying to get across. But let's say, for example, 1 over 3 plus 1 over 6. Well, 3 really has a 1 and a 3 in common, and 6 has a 3 and a 2 in common. So this 3, in other words, matches the 3 across from it, meaning that this 3 here is just missing the 2 that is found from the 6. So we're going to multiply it by 2 here. Same idea here. This x matches this x. This one is just 3 times x, and this one is just 1 times x. So your x values here match, but your coefficients don't. In other words, this one needs a 1, which 1 doesn't really matter so much, but the other one needs the 3. So we're going to multiply this side by 3. What you do to the bottom, you do to the top. So you're now left with 2 plus 12 all over your common denominator of 3x. 2 plus 12 is 14 over 3x. Now let's try it again with 20. So this x is just 1 times x, and this x is 5 times x times x. So similar to what we just did, this x is matching this one. So your rightmost term is just lacking the 1, which doesn't really matter. But the leftmost one is missing the 5 and the x. So we're going to multiply 5x to the other side. So you're left with 5x times 6 plus 7 over your common denominator, 5x squared. Notice that we didn't multiply this side by an x because those match. So your common denominator isn't going to be a triplicate of an x. Okay, we always want to go with the lowest common denominator to make our lives easier. So you have 30x plus 7 over 5x squared. And because 30 and 7 have nothing in common, they can't be factored any further. I do suggest that you guys practice just some of the remaining ones from that side. Now let's go ahead and look at 30. You'll notice that you have a few polynomials down here. So let's go ahead, when you see any sort of polynomials, not only are you subtracting, so you want to make sure you have parentheses, but let's go ahead and factor. Perhaps things are going to cancel and they look a little bit better. That's always going to be our hope, so we're going to strive for that. So when we factor this one, we have x squared, x minus 2. Oh, let's see, 1 and 4, 2 and 2. And that one actually might not be factorable because even if your x down below, notice that even if 2 can get you to 4, they would both have to either be subtracted or added. If you add them, that'll get you to a positive 4, but by multiplying them back together, that'll get you to a negative. So unfortunately, they're not going to cancel out this way. But let's take a look at your denominator. We could say this is really x plus 6 and x minus 2. So when we go ahead and look across to the other side, you'll notice that these both have an x minus 2. So what we can't do is that when we go to look at your common denominator, that left-hand side is just missing this x minus 6 over here. So we'll multiply x plus 6. Excuse me. So on one side, we'll have x plus 6, x minus 1, minus, and because we didn't change anything in your denominator here, we'll just keep x squared plus 4x minus 4 in common. For your denominator, we have it as such. So let's go ahead and FOIL here. So you have minus x plus 6x minus 6. So we have 5x here. When we go and distribute, you're left with negative x squared minus 4x plus 4. So all together here, we should have, actually I'm going to write it above so I can kind of save space. So in your numerator, we'll notice that these x squares are going to cancel. These two can come together to make x. And then these two can come together to make minus 2. So then we have x plus 6, x minus 2, which is going to cancel out with this one over here. So in your numerator, we have 1 over x plus 6. Let's try that process again in 31. Well, above it, we have factoring this one out. I'm trying to figure out your space here. Let's see, we have x squared plus 5x plus 14, which that one is not factorable either, but your denominator, I guess, is factorable. So we're going to do x minus 6 and x plus 4. You'll notice that x minus 6 is the same as the other one. So that just means your left-hand side needs the x plus 4. So over here we have x plus 4, x minus 2, minus x squared plus 5x plus 14. And down below, x minus 6 and x plus 4. So always, I know these aren't factorable yet, but you always want to check to see if they are factorable, because let's say this was, and perhaps it canceled with the x plus 4 here. So then your denominators would indeed match. So that is always our hope. That's what we're going to strive for. So let's go ahead and FOIL it out. So we have x squared minus 2x plus 4x minus 8, negative x squared minus 5x minus 14. So your x squares are going to cancel. See, you have 5x and the 4x, leaving behind a negative x. So that's negative 3x. And let's see, negative 8 minus 14 can come together with 22. Minus 22. I'm just going to check my work really quick because I'm running out of space, and that's when I tend to make mistakes here. Okay, that one looks fine. X squared, negative 2, positive 4x, negative 8. So that canceled with that one. That left behind a negative 3. And then here we go. Down below, we have x minus 6, x plus 4. And 22, it's really 1 and 22, and 2 and 11. And there's no way that it can get to be factored. So unfortunately, that one is not able to simplify any further. And I'm going to check your answer key on that one. So something did go wrong on 31. So let's take a look at where I may have messed up. That's okay. Oh, that's fine. You'll notice I did x plus 2 or x minus 2 here, which does change it quite a lot. Still negative x squared minus 5 minus 14. X squared plus 6x plus 8. There we go. So you're left with, these ones cancel. You're left with just a regular x. And now you have 8 minus 14, which will get you to a negative 6. There we go. X minus 6 and x plus 4. And they're going to cancel. 1 over x plus 4. Now let's try a different one where they don't completely match. And I may have to do that where I might have to just make my own. So let's go ahead and let's see. Let's go ahead. I'm going to change this problem here. Now, if your parentheses, if you don't have anything in common, keep in mind, these are working as a team. So if they have nothing in common, what you're going to be doing is multiplying by the other one. Just like the fraction 1 over 3 plus 1 over 4, right? 3 and 4 share nothing in common. So you're going to be multiplying that side by 3 and this side by 4. The same idea goes here. If they don't match at all, you just get to multiply by what's missing. It's just this whole thing that is missing. So you get to multiply that side by x minus 2 and this side by x plus 1. X minus 2 minus x times x plus 1 all over x plus 1 and x minus 2. Starting to clean it up, we have x minus 2 minus x squared minus 1, x plus 1, x minus 2. Let's rewrite it so that it's in descending order. And let's factor out that negative leading coefficient. This is still over your denominator here. Anytime you have a negative leading coefficient, you want to factor it out and change all of your signs. And then we can try and figure out, is this one now factorable? Will it cancel with one of the below? Well, x squared minus x plus 3, factors of 3, 1, and 3. There's no way that that order can make a negative 1. So unfortunately, that is not factorable. So this is going to be your final solution. And notice that so far, a lot of it has been canceled out. So you only have one term remaining down below. If you're lucky enough where nothing is canceled and it's just 2 or more factors underneath, you're going to keep it in its factored form, in its most simplified form. I believe we are going to just leave it there. We'll do one more. Let's do 42. That looks like a good one. So you see some polynomials. So one more time, we're going to go ahead and factor. This time we get x minus 6 and x plus 1. Oh, this one's pretty gnarly. So because these ones, one more time, actually to emphasize my point even better, because they share nothing in common, we're going to multiply one side by all of that and the other side by all of that. So this one's going to get pretty big. It's 3, x minus 3, x plus 3, minus 3, x minus 6, and x plus 1. If you wanted to unfactor it and FOIL it out so that it makes inserting the negative 3 and the 3 into it, that would be better. I might actually go ahead and jump right into that step. So I might back up for a second because I need a little bit of space. You have 3 x squared minus 9, which makes 3x squared minus 27. And we have minus 3x squared minus 7x plus 6 minus 3x squared plus 21x minus 18. We can go ahead and combine some terms. You'll notice that those two are going to cancel. You're left with 21x. Then you have 27 and an 18, which can combine into negative 45, which 45 and 21, they both share a 3 in common. Actually, yeah, they both share a 3 in common. So we can factor out that 3. You're left with 7x plus, or 7x minus 15 on top. I want to see if I went wrong somewhere on 42. No, 42 is pretty big. You'll notice that they didn't factor out and the 3 here. I would expect you to factor out the numerator as well, just because on the off chance that it does cancel with something below, you were to be able to see it. Same thing here. You'll notice that some of your numerators still aren't factored out. These both have the 2 in common. So your numerator here, we're leaving behind a 2, should look something like this, or even down below it right here. They both have a 3 in common. So again, it just happens that these aren't traditionally factorable like these ones. But again, it's on the off chance that it can factor. And that will be it as far as this video goes.